Good morning. Today we are going into the topic of enzyme. For KSSM syllabus, it is under chapter 5, Metabolism and Enzyme, whereas for KBSM, it is still in chapter 4. The content standard is under 5.2, that is enzymes. Learning standard 5.2.8 correlate the mechanism of enzyme action with the change in the following factors. And the factors that we are going to look into today are only temperature and pH. The success criteria for today's lesson is first, explain how temperature affects enzyme action, and the second, explain how pH value affects enzyme action. Now, we are going into the first factor, that is temperature. How temperature affects the mechanism of enzyme action. Look at the graph. When we want to read the graph, we have to check the x-axis as well as the y-axis. So for this graph, x-axis represents temperature. Y-axis represents rate of reaction. Look at label 1 in the graph. It is at low temperature. At low temperature, the rate of reaction catalyzed by enzyme is also low. From the graph, you can also see that the line slowly going up. It shows that when the temperature rises, the rate of reaction slowly rises as well. Why? This is because the kinetic energy of the substrate molecule increase. The kinetic energy of the enzyme also increase. Frequency or effective collision between substrate molecule and enzyme molecule increases because the kinetic energy for both molecules increases. Hence, the rate of reaction between enzyme and substrate molecule increases. With every 10 degrees Celsius rise in temperature, the rate of reaction controlled by enzyme will also double until it reaches the optimal temperature. You can see the optimum temperature is labeled in the graph. Now, we look at number 2 in the graph. It shows the peak of the graph. It means it is the optimum temperature. At optimal temperature, the enzyme reaction is at its maximum. The optimal temperature for enzyme reactions in the human body is around 37 degrees Celsius, as you can check in the graph. Moving to label number 3, where you can see the graph slowly going down. After reaching the optimal temperature, the enzyme activity decreases until it stops at 60 degrees Celsius. Why? Because at 60 degrees Celsius, the enzyme becomes denature. When the enzyme denature, the chemical bonds in the enzyme molecule breaks. The enzyme are unable to retain its three-dimensional form. Thus, the active site of the enzyme change shape. As a result, the substrate is unable to complement or fit to the active site of the enzyme. The diagram shows how, as the temperature is increased beyond the optimal temperature, the special bond that stabilize the enzyme three-dimensional structure are broken. Hence, the physical shape of the enzyme active site started to change. Due to the changing shape of the active site of the enzyme, the substrate molecule can no longer fit the active site properly. and at critical temperature, the substrate will not fit at all into the active site of the enzyme. At this point, the enzyme is said to have been denatured. Denatured enzyme will not be able to catalyze any reactions. Hence, there will be no product formed. Denatured enzyme is permanent. Hence, even though you reduce the temperature, it will not undo the damage to the active site of the enzyme. Now, we go to the second factor, that is the effect of pH on the action of enzyme. Each enzyme has its own optimal pH value, as you can see from the graph. At optimal pH value, enzyme reacts most effectively. Generally, most enzymes are active at pH between 6 to 8. For example, salivary amylase works best at pH 6.8. However, there are few exceptions. For example, the pepsin enzyme. The pepsin enzyme in the stomach optimal pH is between the range of pH 1.5 and 2.5. The next example is trypsin enzyme in the duodenum. Trypsin enzyme works well in the alkaline medium. The optimum pH for trypsin enzyme is around 8.5. What happens if there is a change in the surrounding pH? The change in the pH value actually changes the charge of the active site of the enzyme and also changes the charge of the substrate surface. This causes the enzyme substrate complex cannot be formed. However, when the pH of the environment returns to the optimum level, the charge on the active site will be restored. Thus, the enzyme will return to function as normal. But if there is an extreme change in the pH value, it will break the structural chemistry bond of the enzyme. The active site of the enzyme will change shape. At this point, enzyme has become denatured. Okay, we have come to the last slide. The task for today's lesson, please refer to the assignment in your Google Classroom classwork. And don't forget to like my video and subscribe my channel. Bye!